On the morning of August 12, 2026, the world will share a rare moment of collective anticipation. Across the North Atlantic, from the rugged highlands of Iceland to the sun-baked plains of Spain, millions of eyes will be cast toward the heavens. They are gathered for a total solar eclipse, a celestial event where the clockwork of the solar system is briefly, beautifully visible to the naked eye. We watch as the moon begins its slow transit, carving a silhouette into the solar disk. We feel the sudden chill in the air and see the shadows sharpen into crescents on the ground. For a few minutes, we expect to be plunged into a midday twilight, only to see the sunburst return in a triumphant flash. But today, we are exploring a scenario where the flash never comes. Imagine that at the height of totality, the sun doesn't just hide behind the moon. It vanishes from the fabric of space-time entirely. This is not just a story about darkness. It is a story about the collapse of a planetary system. I'm your host, and you're watching Stellar Stories. Today, we are breaking down the physics of a world without a star. We will investigate the ghost minutes of gravity, the slow thermal death of our oceans, and the ultimate destiny of Earth as a rogue planet drifting through the interstellar void. To understand why the world wouldn't end the instant the sun vanished, we have to look back to 1919 and one of the most famous experiments in scientific history. Sir Arthur Eddington used a total solar eclipse to prove Albert Einstein's General Theory of Relativity. He showed that the sun's mass actually bends the light of distant stars. But Einstein's work also revealed something else. Gravity is not an instantaneous force. Like light, it has a speed limit, the cosmic speed limit. If the sun were to vanish at this very second, the Earth would remain in a state of celestial denial for exactly 8 minutes and 20 seconds. This is because gravity travels at the speed of light, roughly 186,000 miles per second. For those 8 minutes, the Earth would continue its elliptical orbit around an empty point in space, held by the gravitational ripples of a star that is no longer there. Someone looking through a telescope during these ghost minutes would still see solar flares and shifting sunspots. The photons already in transit would continue to hit our atmosphere, keeping the sky blue and the world warm. But at 8 minutes and 21 seconds, the physics of our world would fundamentally break. The last light would hit the Earth, followed immediately by the snap of the gravitational tether. Earth would stop its orbit and begin to travel in a straight line at 67,000 miles per hour, hurtling away from its neighbors and into the deep dark of the Milky Way. In the first few hours of the eternal eclipse, the immediate fear would be suffocation. Without sunlight, photosynthesis, the process by which plants convert carbon dioxide into oxygen, stops instantly. However, the science suggests our atmosphere is far more resilient than we realize. Earth's atmosphere contains roughly 10 to the 15th power kilograms of oxygen. This is a staggering reservoir. If every plant on the planet died tomorrow, the oxygen currently in the air would theoretically be enough to sustain every human and animal for several thousand years. But there is a hidden biological caveat that complicates this: microbial decomposition. As the world cools and plant life begins to rot, trillions of bacteria will begin the process of breaking down that organic matter. This process consumes oxygen and releases carbon dioxide. While humans wouldn't run out of air in a week, the massive die-off of the global biosphere would accelerate oxygen depletion faster than human breathing alone. Even with this accelerated decay, we would still likely have centuries of breathable air. The real threat to our survival isn't the lack of oxygen, it's the plummeting temperature. Despite the loss of its energy source, the Earth would not turn into a block of ice overnight. Our planet is a massive thermal battery, and the atmosphere and oceans act as incredible insulators. Water has a high specific heat capacity, meaning it holds on to its warmth with stubborn persistence. Within the first week, the average global surface temperature would drop to about 0 degrees Celsius, 32 degrees Fahrenheit. This would be a global winter that never ends. In the tropics, this would be catastrophic, wiping out ecosystems that have never known frost. In the northern latitudes, it would feel like a standard January at first, but as the months pass, the cooling becomes relentless. By the end of the first year, the Earth's surface temperature would plummet. Most climate models suggest the planet would eventually reach a state of equilibrium, stabilizing at roughly minus 220 degrees Celsius, around minus 364 degrees Fahrenheit. At this point, the Earth is no longer losing significant heat to space because there is so little heat left to lose. We would be a frozen, silent rock, but deep within, the Earth's core, still hot from primordial formation and radioactive decay, would provide a tiny, lingering pulse of warmth. As the surface becomes a frozen wasteland, humanity's only hope for survival would be to look downward. Geothermal hotspots like those in Iceland, Yellowstone, or the volcanic ridges of the Andes would become the last bastions of civilization. We would build deep pressurized bunkers, tapping into the Earth's internal heat to generate electricity and grow food in hydroponic vats lit by artificial LED suns. While humanity struggles in bunkers, life in the deep ocean might not notice the disaster at all. As the surface of the sea freezes, it creates a massive insulating shield of ice. Because ice is less dense than water, it floats, protecting the liquid water below from the vacuum-like cold of the atmosphere. Miles beneath the ice, hydrothermal vents, powered by the Earth's internal chemistry, would continue to pump out mineral-rich, superheated water. The creatures living there, which rely on chemosynthesis rather than photosynthesis, would be the true survivors of the eternal eclipse. They have never known the sun, and they do not need it to thrive. Eventually, even the atmosphere would succumb to the cold. As we approach that equilibrium of minus 220 degrees Celsius, the very air we breathe would undergo a phase change. Carbon dioxide would freeze first, followed by the nitrogen and oxygen. They would condense into liquid and then freeze solid, falling to the ground as a ghostly, translucent atmospheric snow. Earth would now be a silent, airless ball of ice, drifting through the interstellar medium. But this is not an uncommon fate in our galaxy. Modern astronomy suggests that rogue planets, worlds that have been kicked out of their home systems, may actually outnumber the stars in the Milky Way. Earth would simply be the latest addition to this nomadic fleet. Perhaps in some unimaginably distant future, our rogue Earth might pass near another star. Its ice might melt, and its atmosphere might thaw, revealing the frozen ruins of the civilization that once called it home. The eclipse of 2026 will only last a few minutes, but it serves as a profound reminder. We live on a fragile miracle, anchored to a star that provides everything we are. When the light returns on that August afternoon, we might just look at the sun and realize it is the most important story ever told. I'm your host for Stellar Stories. If you enjoyed this journey into the dark, subscribe for more deep dives into the cosmos. For now, enjoy the light while it lasts. Thanks for watching.